at-home version here, as you can tell. But we are looking at balancing reactions in this section of the notes. And with your balancing reactions, we're going to have what's called a skeleton reaction, which is an unbalanced reaction. What a skeleton reaction means is you don't have the same amount of elements on your reactant side as your product side. When a reaction is balanced out, if you have 4 oxygens to start with, you're going to have 4 oxygen in the products as well. And so we're going to use something called a coefficient to balance everything out. So your skeleton reaction is just another way of saying unbalanced reaction. And the reason why we have to balance out these reactions is because we, like I said, have to have the same number of each element on both sides of the reaction. And that is actually because of a law. It's going to sound very similar to a law that we've had earlier in the year. That law is called the law of conservation of matter. Before we had the law of conservation of mass, which says that mass cannot be created or destroyed. It merely transfers from one form to another. On this one, we have the law of conservation of matter. And that just says that matter cannot be created or destroyed. It merely transfers from one form to another. So if we start with 2 zinc in my reactants, I have to have 2 zinc in my product because I cannot create or destroy those zinc. If I have 8 oxygen in my reactants, I have to have 8 oxygen in my product again because you have to have the same amount on each side because you can't create it and you can't destroy it. So we're going to add what's called a coefficient to the front of an element. And with your coefficient, it's like this number 2 right here. It goes in front of the O2 molecule. Remember, oxygen is diatomic, so it's found when it's all by itself as O2. It needed 2 of those oxygen molecules to balance everything out. So you have 1 carbon, the black one, and 1 carbon. You have 4 hydrogen, and when you add a 2 in front of the H2O over here, we have 1, 2, 3, 4 hydrogen. And then for my oxygen, I have 1, 2, 3, 4 with that 2 out front there. And again, that's just adding another molecule of that oxygen molecule. And then we have 1, 2, 3, 4. So that's a balanced reaction. Without those coefficients, that was called a skeleton reaction. And what we're going to do is we're going to go through the rules on how to add in these coefficients to make it go smoother. There's some tips and hints. There's no real steadfast rule on this is what you need to do to balance out these reactions. It's just kind of, hey, here's some hints on how to get this to work better. But it is a problem-solving type issue, and so you're going to have to go through and just work out the problems one at a time and just go through each element to make sure that they're all balanced by adding in these coefficients in front of the compounds. So I have some hints here, and we're actually going to use these as we go through the example problems that I have. I have 4 examples that we're going to do together. The first one says to make an inventory. When you make an inventory, you're going to look at your reactants and your products. You're going to make sure that you have the same amount of each element on both sides. If you have oxygen or hydrogen, you want to save those for last. Usually they end up kind of working themselves out anyways, and they're going to be your biggest headaches. So if you save oxygen and hydrogen for your last elements, usually that helps. The next one is really important. If you see a polyatomic ion on your reactant side and on your product side, keep it together. Even if you have to put parentheses around it, like if you have sodium nitrate and that nitrate is not in parentheses on one side, put parentheses around it to keep it together, because when you split it up, you start having to add in all kinds of numbers and it gets kind of crazy. So it just makes your life a lot easier. Sometimes water can be split up into HOH, and I'll show you an example of that when we go through the examples. But you're going to see this in an acid-base reaction. Acids start with hydrogen, bases end with hydroxide typically. So if you have an acid-base reaction, you might want to break up your water, H2O, into HOH, hydrogen hydroxide. It makes the balancing a little bit easier. And then with your coefficients, you have to reduce them down. So if you end up with a 2, a 4, a 4, and a 2 for your coefficients, you have to simplify it. If you end up with like a 3, a 6, a 6, and a 3, you have to simplify it. So if all of the numbers are divisible by the same number for your coefficient, you have to reduce it down. And then finally, if elements are split, you want to save those for last. Like if you have oxygen in one of the reactants and in the other reactant, you want to save that for last. So as we go through the examples that I have here, I'm going to switch over to my camera and we're going to do these examples that are in your notes. So I have, sorry about the bad shadow on that one, I have kind of weird lighting in my kitchen. But we have this vanadium 5 oxide. It's reacting with calcium sulfide to make, is what the arrow means, calcium oxide and vanadium 5 sulfide. So the first part of your hint, it says to make an inventory. All we're going to do is we're going to write down what elements we have on each side. So I have vanadium, I have oxygen, I have calcium, and I have sulfur. And I'm just going to write down how many of each of those elements are on my reactant side and how many are on my product side. So here I have 2 vanadium, I have 5 oxygen, 1 calcium, and 1 sulfur all on my reactant side. On my product side, I have 1 calcium, 1 oxygen, 2 vanadium, 5 sulfur. So when we're done balancing, my inventory is going to have the same amount of each element on both sides. How I get that equal is in these little lines here in front of the compounds. You can't add these anywhere else. They don't go after, they don't go in the middle, they go in front of the compound. We can add a coefficient there. Typically, we don't write the number 1. For your assignments that you're going to have to do or you're doing it in Schoology, you're going to have to type in the number 1. But typically, we wouldn't write a number 1. It would just be a ghost. But you might need a 2, a 3, a 4, a 5, 97. You can put any number there in order to balance it out. So usually I just kind of go through my list. We want to save oxygen and hydrogen for last. So I have vanadium, 2 and 2. That is already balanced. I don't have to do anything with my vanadium. My oxygen I'm going to skip over. Calcium I have 1 and 1. I don't have to do anything there. My sulfur, I have 5 on this side. I need 5 over here. So we're going to have to go back to like 3rd grade multiplication tables. We're going to think about what, we're going to fill in the blank, what times 1, because there's 1 right here, will give me the 5 that I need. So I put a 5 right here. 5 times 1 gives me 5 sulfur. But these two are stuck together. So with those two stuck together, I don't know why that's so blurry, I'm sorry. Let me see if I can, there we go. So with these two being stuck together, I now also have 5 calcium. So I had to adjust that as well. So that 5 goes to my calcium, it also goes to my sulfur. What is going on with my document camera? Let me see if I can fix that. I'm sorry. Okay. Now, by calcium, I have 5 over here. I need 5 on this side. So again, I'm going to think about that math problem. What times 1, because there's a 1 right there, will give me the 5 that I need. So if I put a 5 right there, that changes my calcium to 5. That also changes my oxygen to 5 because they're stuck together. So I have 2 and 2, 5 and 5, 5 and 5, 5 and 5. That balances everything out. So this is a balanced reaction. So when you submit it, the blank means 1. So you would have 1 of these, 5 of these, and then 5 of those, 1 of those. Now again, when you submit your assignment into Schoology, you're going to have to type in a 1. It's not going to let you accept a blank. And if you want to write in a 1 when we're doing these, you definitely can, because we're going to pull these numbers second semester in order to do the math problems where you're going to write in a number 1 anyway. So you can write a 1 there, you don't have to. I don't really care one way or another. Now to show you another example, to go through kind of one of the rules that we talked about, here I have sodium nitrate. Nitrate, NO3, is a polyatomic ion. It is also over here. So with this, I'm going to lock parentheses around it, and I'm going to keep the NO3, nitrate, together as one functional group. So I have sodium, I have nitrate, I have lead, and I have oxygen. Now this oxygen is different than this over here because this oxygen is a part of the NO3. So I'm not going to count that in with that. I'm going to keep it separate. So I have 1 sodium, 1 nitrate, 1 lead, 1 oxygen. On this side I have 2 sodium, there's 2 right there, I have 2 nitrate, because there's a 2 outside my parentheses. I have 1 lead, and I have 1 oxygen. So I need to balance everything out to be the same on both sides by adding coefficients. We put coefficients in front of the compounds, and sometimes it's helpful to draw out those lines where you can actually write them down. So I'm going to start with my sodium. Sodium, I have 2 on this side. I need 2 over here. If I put a 2 in front of that, that changes my sodiums to 2, my nitrates to 2. That's a balanced reaction. Everything's the same on both sides. So again, you can fill in the ones if you want to. You can leave it blank. I don't really care one way or another, but technically the ones wouldn't be there when you just saw a balanced reaction. So this is a case where you see this nitrate on both sides of the reaction. They're identical, so you can keep them together in your inventory. Now when you're doing these, hopefully you're going to get to a point that you don't have to write this inventory out. It's not necessary. I'm not going to ask you for your work or anything like that. Some people can kind of bounce through these and say, oh, I've got 2 vanadium, I've got 2 vanadium. I've got 5 oxygen, I need 5 oxygen over here, so if I put a 5 here. So you can kind of work through it, and hopefully you kind of get to that point where you don't have to write these out unless you get to a really challenging problem. But in the beginning, I'll always write out my inventory just so you can see exactly what I'm doing. Now I do have 2 more examples here. I have sulfuric acid and aluminum hydroxide. We are making aluminum sulfate and water. So in this one, I have H2SO4. SO4 is a polyatomic ion. It also appears over here. So in my inventory, I'm going to keep it as SO4. Now I have water. When you have water, you want to look at the other side of the arrow. When you look at the other side of the arrow, you're looking for hydrogen and hydroxide in 2 separate components. Like right here, I have a hydrogen and I have hydroxide. This is going to be a case that it's going to be more helpful to break this up into HOH. You don't have to do this. You can keep it as hydrogen and oxygen. It's just going to help balance it out a little bit quicker. So with this one, in my inventory, I have hydrogen, I have sulfate, I have aluminum, and I have hydroxide. So here I have 2 hydrogen, 1 sulfate, 1 aluminum, and 3 hydroxide. Over here I have 2 aluminum, 3 sulfate, 1 hydrogen, and 1 hydroxide. So I need to add coefficients in front in order to balance everything out. We save my oxygen and hydrogen for last. So I'm going to skip over hydrogen and I'm going to fix my sulfate first. Here I have 3 sulfate. I need 3 over here. So if I put a 3 in front of that compound, that changes my sulfates to 3. But then that also gives me 3 times 2 is 6 hydrogen. Again, I'm saving my hydrogen for last. So I'm going to skip down here to my aluminum. Aluminum has 2 over here. I need 2 over here. So if I do a 2 times 1 gives me 2 aluminum, but that also changes my hydroxides to 2 times 3. So 2 times 3 is 6 hydroxide. So now I need to fix my hydroxide. I have 6 over here, 2 times 3. I need 6 over here. So if I put a 6 in this front blank here, that's going to change my hydroxides to 6. It also changes my hydrogens to 6. So I have 6 and 6, 3 and 3, 2 and 2, 6 and 6. That balances everything out. This is technically a 1, which is really a ghost. We don't usually write it. So it's a 2, 3, 1, 6 to balance that one out. The last one that I have for you guys, it's called a combustion reaction. We'll look at types of reactions later on this week. But we only have carbon, hydrogen, and oxygen on these. I do have a water. And with my water here, I'm going to look at my other side and I'm going to look for hydrogen and hydroxide in 2 separate components. So I have a hydrogen, but I don't have hydroxide. So this is a case that I cannot break this up into HOH. I'm going to have to keep it as hydrogen and oxygen. So on this side of the reaction, I have 2 carbon. I have 6 hydrogen. I have 1 oxygen here, and I have 2 over here. little plus sign means we're going to add it together. So 1 plus 2 gives me 3 oxygens total. On this side I have 1 carbon, my hydrogen I have 2, and then my oxygen I have 2 plus 1 is 3 again. So I need to fix my carbon first. I have 2 over here, I need 2 over here. So I'm going to start with a 2 out front. That changes my carbon to 2. Now my oxygen I have 2 times 2 is 4, plus 1 is 5 oxygen. Now my oxygens are split, so I'm going to try to fix my hydrogens next. Because they're broken up, we're going to see if we can't fix it with my hydrogen. So I have 6 hydrogen over here. I need 6 on this side. So if whatever I do, I'm going to have to take something times 2 to give me 6. If I put a 3 right here, 3 times 2 gives me 6 hydrogen. But then my oxygen, I have 3 right here, and I have another 4 right here, 2 times 2. So 4 plus 3 gives me 7 oxygen. So we had to fix that one again. So now I need 7 oxygens on this side. Now looking at this, I have 1 broken off, and no matter what, I'm going to put something here times 2. So we kind of have to think through some algebra here. So I have basically like 1 plus x times 2 to get my answer. It has to equal 7. So when we look at this, if I put a 3 right here, 3 times 2 is 6, plus 1 is 7. So now I have a balanced reaction. Again, you can write that number 1 there if you want to or not. It's a ghost, it doesn't really matter. But these are some of the more difficult ones that you'll see, these combustion reactions. But if you remember to go in the order of carbon, hydrogen, then oxygen last, that will help you go through that process a little bit easier. If you have any questions, ask. Otherwise, I hope you kind of remembered very quickly how to balance out chemical equations. And again, I'm just an email away if you ever need anything.